Hello guys, welcome to my video on modes of failure. So why column fails? What are the reasons for these failures and what are the preventions? In this video we are going to discuss 6 failure types. Okay, we will also discuss that why it is important to learn about these failures. So guys, before we dive deep and learn more about modes of failure, you guys are requested to please subscribe to the channel and don't forget to press the bell icon to get video updates. So let's get started. First of all, let us understand that why it is so important. Why it is important to learn about the modes of failure in columns. So here is the answer. Understanding the modes of failure in columns helps engineers to design safe structures, avoid sudden collapse, and improve durability and service life of the structure. So let's start with column. What basically the column is? A column is a vertical structural member primarily subjected to compressive loads. Sometimes combined with bending. Vertical structural elements. Columns are vertical structural elements that act as supports and primarily support axial compressive loads. As you can see over here, there are different shapes and sizes of the column. It could be circular, square or rectangular or in polygon shape. Okay, and these are few other types of columns which are used for aesthetical, architectural or ornamental purposes. These are also types of columns. Okay, so the basic purpose of the columns are to hold the ceiling and roof and weight acting on them, and these are cylinder members. As you can see over here, cylinder members, to understand this, is like if the width of the structure or structural member is very less as compared to its one of its dimensions, such member is called as cylinder members. Okay, column failure. So column may fail in different ways depending on cylinderness ratio. What is cylinderness ratio? It is the ratio of effective length of the column to the minimum radius of gyration. So basically guys, these are two different topics, and it is very lengthy discussion about these two topics. I have already made a detailed video. You can simply click on the I button to watch that video, or you can watch it anytime later on. Okay, the link is given in the description. So the failure depends upon cylinderness ratio and loading conditions. There are basically two types of loading conditions. The first one is axially loaded and the second one is eccentrically loaded. And eccentrically loaded columns are further categorized into uniaxial and biaxial. Okay, so axially loaded column, as you can see over here, this is the center of the cross section of the column. Okay, and the point of application of load is right above the center. It is passing through the, or you can say passing along the centroid of the structure. Okay, whereas in uniaxial eccentric column, the point of application is either on x-axis or could be on y-axis. Okay, then biaxial eccentric column, as you can see over here, the point of application of load is anywhere between the x-axis or y-axis of the load. It could be anywhere between these places. Okay, such type of loading is called as biaxial eccentric loaded column. Okay, and the third main cause of column failure is material quality. So guys, these 3 points are very important, which play a vital role in the sustainability of the structure. Now let us discuss the major modes of failure in columns. The first one is crushing, which is also called as compressive failure. It occurs when the compressive stress exceeds the strength of the concrete or steel. It's mean that when the structure become overloaded, okay, it crush. Okay, it is very common in short columns. What are the reasons for this failure? The first one is overloading. Obviously when the applied load is more than the design load of the structure, it will crush down. Okay, it is due to overloading. The second reason could be poor quality concrete, insufficient cross sectional area, low grade materials. And what are the preventions? Proper design as per codes. Okay, use of adequate concrete strength and correct safety factors, quality control during construction. Okay, this is all about crushing failure. The next one is buckling, or it is also called as elastic instability failure. It is sudden lateral bending of the column, mostly occurs in long or cylinder columns. Okay, and what are the reasons? It is due to high slenderness ratio. Okay, for now, to understand the slenderness ratio, it is basically the ratio of length. Okay, the ratio of length or height of the column to the radius. Okay, just to understand in simple words, it is the ratio of length to the width. Okay, if it is high, if this ratio is high, the column is more prone to buckling. Okay, and insufficient lateral support in the form of ties. If you decrease the spacing between ties, this failure could be or can be avoided. Okay, inadequate stiffness and eccentric loading. I have already discussed that eccentric loading is one of the main cause of these failures. Okay, and prevention. What are the preventions? Reduce effective length, provide lateral bracing, increase cross section, and proper alignment during construction. The third type of failure is combined compression and bending failure. Column fails due to axial load plus bending moment. Okay, I have discussed the type of loading in the start of this video. Okay, axial load is the load which passes through the centroid, or you can say the center of the structural member. Okay, such type of loading is called as axial load, and if it is accompanied by bending, so this type of failure can occur, which is called as combined compression and bending failure. It is very common in real structures. And what are the reasons? Eccentric loading, obviously, unequal load distribution, wind or seismic forces, and construction inaccuracies. How can you prevent this failure? Design for axial load and moment interaction, use interaction diagrams, ensure proper load transfer, and accurate construction practices. The fourth type of failure is shear failure. The sudden diagonal cracking and failure. Due to shear failure, sudden diagonal crack appears. As you can see over here, this is diagonal crack, and it is more brittle and dangerous as it is very sudden. Okay, there is no time to evacuate building, it occurs suddenly. Reasons. What are the reasons? High lateral loads, inadequate shear reinforcement, poor detailing of stirrups. What are the preventions of this failure? Is to provide sufficient transverse reinforcement, follow code specified stirrup spacing, proper detailing at joints. The fifth type of failure is failure due to reinforcement problems. There are three types of failures which are due to reinforcement problems. First one is yielding of steel. The second one is buckling of longitudinal bars, and third one is corrosion of reinforcement. So these three types of reinforcement problems could be the reason of failure of column. What are the reasons? It is due to insufficient cover, poor bar spacing, aggressive environment, and improper compaction. How to prevent the failure which is due to reinforcement? Okay, the first one is adequate concrete cover, proper spacing and ties, corrosion resistant materials, and regular inspection and maintenance. The sixth type of failure which occur in column is foundation related failure. Column fails due to uneven settlement or foundation movement. Reasons could be weak soil, poor foundation design, excessive loading. How to prevent foundation related failure? By proper soil investigation, use suitable foundation type, and uniform load distribution. Common construction errors leading to column failure. The first one is improper curing. honeycombing, as you can see over here. Due to poor farm work and due to poor mix design, this type of defect can occur in your column, which is called as honeycombing. Misalignment of the column, as you can see over here, columns can be aligned by four different types of aligning techniques. The first one is plumb bob method, the second one is spirit level, the third one is center line checking, and fourth one is diagonal measurement. If you guys really want to learn about these techniques, that how can you align column on site, let me know in the comments. I will make a detailed video on that topic. And the other construction error could be poor compaction and unauthorized changes at site. Now let's have a quick recap. So these are different failure modes of the column. The first one is crushing. The main cause of it is overloading, and it could be prevented by adequate strength. Okay, as it is due to overload. Okay, provide adequate strength. The second mode of failure is buckling. It is due to slenderness, provide bracing or lateral supports. Okay, the third mode of failure is bending. It is due to eccentric loading, and proper design can prevent this type of failure. The fourth mode of failure is shear, which is due to lateral force, and by adding lateral reinforcement like stirrups, you can avoid this failure. The fifth type of mode of failure is due to reinforcement problems. The main problem is corrosion. So by using corrosive resistant materials, you can avoid this failure. The sixth type of failure of column is foundation. Due to foundation, it is due to mainly due to weak soil, and soil investigation, proper soil investigation can avoid this type of failure in column. So guys, that's all for today. For similar informative civil engineering related videos, you are requested to please subscribe to the channel, and don't forget to press the bell icon to get video updates. That's all for today.